Okay, so I've been working for the past couple of days on this particular project. Thanks to Dora, I got a chance to work on it, and this basically will let us play with Scylla Cloud X, just like we do in the automation framework. So the automation framework was already there for the normal Scylla Cloud, but I made some changes to it so that it's more compatible with the Cloud X part of things. So we don't have the complete API available, um, but fortunately, the normal API still works with a cluster that is already created, right? So unfortunately, we can't really create a cluster through the API. We can't really scale in and scale out the cluster through the API just yet, because it's still dealing with just purely number of nodes, like how many number of nodes do we want in the cluster. So we just set it there and it will scale as per the original Scylla Cloud logic. So we can't really do those minimum CPUs that we want or minimum storage that we want. So those things are not available yet. But anyway, so what we have right now is that I'm going to create a new cluster here using Scylla Cloud account and Scylla Cloud X Cloud, of course. And over here, I'm going to select Singapore because it's closer to me. And over here, I will select I for eyes, and the minimum CPUs I want is, let's say, 16 CPUs. So this one will give me a small cluster of per AZ, 1x large and one large node. I think that should be enough. If I give it 1 TB minimum, I don't think it will make a difference. Yeah, it doesn't at the moment at this particular size. So this is a decent cluster with a decent cost. So I'm going to just give it a name. I think that is important. So let's give it this one and create. Did not work. Okay. So what I want to do here is that I will not use the public internet. I will use a VPC peering gateway. I don't want to touch it. This number, of course I can change it, but let's keep it as it is. And what this will do is that this will make this cluster a private cluster. So that basically we will need to use VPC peering to talk to this cluster. I cannot connect to this cluster from my computer, from my local laptop. I need to be able to, I will have to connect to this from a VPC peered machine. So it is going to take around maybe 5 minutes or so. So let's resume once it's done. All right, so the cluster is ready. If I go to all clusters, we should see it here somewhere. Yeah, there it is. And all I need to do is I need to copy this cluster ID first and open up my automation configuration file, and under this cluster ID C1, this cluster ID, I just paste it here. And what will happen that this is going to be using the Scylla Cloud API provider for Terraform. So it is going to use that to import this cluster into the Terraform state file, so that the Terraform is aware of all the infrastructure and hardware that is being used by this cloud instance. So luckily or fortunately, the cloud provider still works with the Cloud X as long as it's already created. So we can't create a new cluster with the API, at least not the Scylla Cloud X type clusters, but the API is still good to use for accessing this cluster's details and getting some information out of it, like the user IDs, the passwords, and all that. So those information, the cluster name, the Scylla version, the user ID, and the password are going to be pulled automatically based on this cluster ID. So I'm going to save this and minimize this again. So the next thing we want to check is the connections. So it is still showing disabled, so it should refresh anytime. It should have already been enabled because the oh no, it's not going to be enabled. Yes, because we haven't done anything yet. So if I look at, if I click here, so there is no connection here, so nothing was created. So we still need to add a new connection like VPC peering or transit gateway. So we are going to go back, and I am going to open up a terminal, and I'm going to import. So I'm going to run this Scylla SCX. SCX is the alias for the Python code that I have written here for this guy, and import X is the argument to import uh, the cluster ID specified under the C1 alias. So I'm going to do this. So what this is going to do is this will um, import this cluster, the Scylla Cloud cluster, into Terraform state file. So that will give us everything, and we can already see that there's a username, password, and the cluster name, the cluster IP, cluster version, and the cloud provider, and the number of nodes. So everything is already there. So it's already able to get access to those. So this has been updated in my variables.yaml file. So yeah, so it is working. So if I go back to my file, I should be able to see those details here. You see that the name is updated, the version is updated, and the Scylla user and the password has already been updated into this file. So that's all I need from this file. The other arguments are latte related. So it is going to be creating a key value table using latte for running. So we can use Cassandra stress or latte. So it's based on this argument here. And the latte number of connections per shard is going to be 1. The concurrency per shard is going to be 32. And the number of loader threads. These are basically, loader threads are basically for doing the initial data load. And then we have a number of stress threads. Where's that? Stress threads. So these are basically for running a mixed workload, a read and write workload, like 1 write and 4 reads here. So that will be based on this ratio. And the desired cluster size is going to be like how much data do we want to populate into this cluster when we run the initial data load. So 1 basically means 1 terabyte. And I am going to make it a small one. So let's say 0.25 terabytes. So that is something like 250 GB. I'm going to save this as it is. And going back here, so the setup is already done. So what this would have created is, this would have created a VPC for us. There's a VPC ID, and this would have already mapped or created a created a private connection between or VPC peering between my own AWS account and my own VPC to the Scylla Cloud. So we'll verify that very quickly here. So if I come here and go back to all clusters, so this is my cluster. So if I do a view here, so this one should refresh anytime, hopefully. Let me click here. No, it's not done yet. So it's still, yeah, there you go. So it took a few minutes. It's still showing as pending. So it's still working in the background with my own AWS account. So it should refresh as completed or ready. Let's refresh this page. All right, so it's still pending. So we'll give it a few more minutes. Yeah, it's still showing as disabled. Oh, did it update? Yeah, there you go. So it has worked its magic in the backend already. So even though the scripts were all done, so AWS was still syncing up with the Scylla Cloud, and then we can already see like it's enabled, and we can see that this VPC peering has been activated, and that's great. So what we want to do next is to go back to EC2 instances. So we don't have anything running, so I haven't created the loaders yet. That's the next command or next thing that we are going to do. If I go to the VPC side, we should be able to see that there's a new VPC created with the cluster name like the X automation Faisal and loader. So this loader VPC has been created. If I view that, so we can see that the subnets are all created, one subnet for one loader machine, because I selected 3 loaders, and then the route tables are created, and the internet gateway routes are already configured. So everything looks good. What we want to check finally is under VPCs is the VPC peering part. we already know that is created, but let's look at the VPC peering connection. So we have one active VPC pairing, and we can already see this one is with my own VPC to the X automation VPC. So this is between the two. So this is Scylla Cloud, I believe, and this is my own VPC that was created between the acceptor and the requester siders are all there. So that's cool. Next thing we want to do is let's go back to general. So I think it's all ready. So I'm going to minimize this, and we are going to run this loader setup. So loader setup, yeah, this guy. So this one is going to create those loader machines. If we go back to the configuration file, so we have defined 3 loaders, right? So, and then the type of loader machines are C7i 8x large. So 3 8x large C7i 8x large machines are going to be created as loaders. Yeah, so let's give it a few minutes, and we'll resume once it's done. All right, so it is done. So this process basically created those 3 instances with these 3 IPs as we see here, and it also installed Latte on those 3 machines. If we scroll up a little bit, we could see that it also set up JDK, rsync, and some other stuff. Plus, it also configured the Cassandra stress. Yes. So all those things were done by this machine, by this particular process. So now what's next? So we already have 3 nodes cluster running, not 3 node cluster, sorry, three AZs cluster running on Scylla Cloud, and on the AWS side, if we go back to EC2, we should be able to see those 3 loaders have been created now under the same VPC, which has been paired with our Scylla Cloud cluster. So all looks good right now. What I want to do next is that we will run initial data load. So SCX init load C1. So what this will do, this will generate stress test scripts based on the configuration that we have given in the variables.yaml file, like the number of connections, number of concurrency, and the profile to use, like the key value profile to use, and the throttling value, how many threads to use, all that stuff. So it's already triggered. So what I will do next is to go to the Scylla Cloud, and I will open up the monitor for this cluster. We should be able to see immediately that there's some load coming into this cluster because we just started the initial data load. So we have total 18 cores, and we can already see like 28.2K ops are running on this cluster, and this cluster is pretty good utilized right now, on a 90% or 95% utilization for each node, even though the reactor is still like 18%, so there's still a lot of capacity left. But looking at the individual nodes, so they are fully booked kind of. So let me do a quick refresh, auto refresh, to see how it looks like, how many ops is this cluster currently doing. Yep, so it's like almost already like 100K ops at the moment, with 7 millisecond write latency, 2 millisecond reads, or 2 millisecond writes, and 7 milliseconds is a P99. Yep. All right, looks good. So I'm going to just for the sake of this demo, I'm going to kill this process. So to do that, I will start the UI. So that's this python -u app.py. So this will start the backend server for the Flask app, and on a new window, I will launch the browser or the app itself. So if I look at the node status here, so this is my cluster. So if I look at it here, so we can see that there are 6 nodes, X large, large, X large, and large. So 3 X large and 3 large nodes. We can also see the network speed for each node, the number of vCPUs per node, the storage capacity, and the cider blocks, of course. So what next to do is to I think the initial data load is already running. So I will do I will basically check the tail logs. So this will generate, or this will give us like how this cluster is currently doing. So based on the number of threads and number of connections and concurrency we have given in the config file. So it is like this is P99. This second row is P99. So it is okay, not great, not bad. So it is because we didn't throttle it, and based on the values that we have given, so maybe is a bit too much load for this cluster, as we can already see here that these nodes are pretty heavily used, like 46% total pressure on the server, and yeah, so the cluster is busy. So what we will do is I will stop this log for now, and I will kill this load. Okay, and I will run a stress test. So looking at the stress test, if I open this config here, and under the stress test section, we can see that the stress throttle is set to 200k. 200k may be too much. Let me edit this and change this to maybe 100k and save it. So the throttling will be on 100k, and the number of stress threads is going to be 16. And because remember there are three loaders, so this 16 will be divided between those three loaders. And the concurrency will be 32 concurrency per shard and one connection per shard. All right, so let's do that. I will minimize this again and I will run stress test. Looking at the monitor, I think it should be already like going down. Yeah, it's already going down because we have killed the loader. But now we have triggered the stress test. It's already triggered. The scripts have already been uploaded to the three loader nodes very fast. And if I look at the tail log again, so now it is generating the tail log. So again, we're looking at it. It looks pretty bad. These are the client latencies. So it means that the configuration I have given here may be not optimal. So I may need to fine tune this a little bit. But anyway, so this is just a demo, so it's fine. So looking at how the cluster is doing, yeah, so 50k, so it should get up to 1000k or 100,000k, maybe not, because it's already 95% per node, so may not be able to reach that number. Yeah, so maybe my configuration is a bit too aggressive for this cluster, but anyway, so it's moving up. So this is already 70%, so it's probably at its peak or max capacity already. So let's give it a few more seconds just to see if it goes any higher. Probably not. All right, so it's almost getting there. But the latencies, client latencies are creeping up, as we see here, because we are really pushing this cluster to its max. So let me do one thing. I think this probably may be a bit too tough for this cluster. I will try to maybe give it 80,000. Let's do that. Save and stress test one more time. So this will trigger the test one more time. All right, cool. So it is done. So now this will of course refresh again. So it will go down and start ramping up one more time. But what we will do next is we'll go back to the console, and we will edit this this capacity from 16 to maybe let's go to 32. So 32 is going to ramp up this cluster to 2x large. So what did we have with 16? Yeah, x large and large. So with 32, we'll get 2x large and x large for each AZ. So let's save it. and this one should change very quickly based on my updated capacity. Yes, so 32, and it's on the back end, it's actually start going to scale the cluster out to this new capacity. So that's how the scaling works at this moment. It's going to take a while, so just keep note of the time. So the time is 11:21 p.m. right now for Singapore. And if I go back to the cloud here, and I'm going to stop recording or pause recording, and then so while this scale out is happening, if we look at this front end, we can check the progress through here. Let me tail the logs one more time for the cluster. So we can already see like it's getting better. So maybe the nodes are already added and the latencies are coming down. So if I look at the progress, so click on this one. So this basically gives us a progress using the Scylla Cloud API to check the cloud status. So what is showing right now is that there's a resize request that was submitted by me, but somehow this always shows as the status returned by this API is always failed. Not sure why, but this wasn't like this on the normal Scylla Cloud. So probably something to do with this Cloud X, how those values are returned, or how maybe this API is not 100% compatible with it. So it's showing as failed status. But clearly, the progress is showing some number, so it is actually progressing. And the latencies we can already see like they are very well controlled now compared to previously. So they are literally like within 10 millisecond, the P99 numbers at least. So hopefully the cluster is already scaled out, but it's not showing here yet. Let's stop this progress update and we can check on the node status. So this should give us if there's new node already joined. Yes, there are. You can see like these three nodes are joining the cluster, right? So they are showing as joining. So they have a lot more capacity. So as you can see, 2x large. So let's see how this goes. The progress will keep on refreshing if I keep this running like so. And once it is 100% ready, it will show 100% here, of course. That is when we will know it's done. So I'm going to pause this recording anyway. On the cloud portal, the Scylla cloud portal, we can also see those nodes are joining. It's still showing as down, but they are joining the cluster as we see here. This is the same status that we got when we run the Scylla Cloud API call on the UI. So if we look at the UI, the nodes have actually already joined the cluster successfully, and then they are showing as active and normal. So this is great, but this guy is still, the API is still showing 10% progress, because I think it's still doing a lot of things in the backend. It will have to update the monitoring dashboard, the Scylla manager side. So a lot to do for the cloud. But as far as the scale out is concerned, the scale out has actually completed, I think around, if you look at the time here, 11:28. So it was actually completed around 11:25. So you can say like it took 5 or 6 minutes to do a resize or scale out of this cluster. So that's really awesome. What does the dashboard shows? The dashboard is also updated. So we have 9 nodes cluster, and then we can already see like there's something happening here. The load is much lower than last time. And if we look at the detail panel, go by instances, and we can see like they're nicely balanced. But of course, because of different instance types, there are two different workloads that those instances are currently handling. So this is the important thing to understand. Looking at the tablet distribution, yeah, so the tablets basically have already balanced. So that's awesome. Very, very fast. That's also because there's not much data to begin with, but yeah, there you go. So the scale out is already done. And over here we can see that all the nodes are up and running. They are running successfully, and then we are running a stress test already on this cluster. So what we will do is I will stop this progress because this is still showing as 10%. So, but eventually it will complete and show 100% when everything in the backend is done. I will stop tailing and I will update this stress test to maybe 200k. So let's see what happens with 200k, just increasing the number of throttle. So save, okay, and let's do stress test. Let's run it one more time. So now our cluster can support more load because we have scaled it out. And as you can see, like thanks to the Cloud X, it was very, very fast. So tail the logs again, and let's see if it becomes any better or it is still in a painful state. No, it's not. So we can see that now the throughput is like 66,000 per node. So again, remember these logs are coming from one loader machine. There are 3 loaders. So each loader is doing 66,000, which basically means, yeah, around 200k for if we combine all of them together. But yeah, you actually see the client latencies are creeping up. It's just a configuration on the loader side that you have to finalize, like what to show and what not to show. But yes, so looking at the monitor, how are the latencies looking like on the monitor side? So we are already on here. Okay, so let's look at the, yeah, so the database latencies are not looking bad. Like they are still within 5 milliseconds or so. Let's do a faster refresh. Maybe they are higher because it was not refreshed. No, I think they are still good. Yeah, so they are still, yeah, they are still well below 5 milliseconds. Even this is 90%. P99s and yeah, read and write latencies are still good. Some nodes are showing high latencies. Yeah, it may be just because of the load. The cluster is still not able to handle that much. If we go back to the overview, yeah, there you go. Yeah, so the nodes are stressed. So some nodes don't have a lot of data, a lot of load currently. So that's weird. But everything else, all the other nodes are very, very heavily occupied. Not sure what is going on with this particular node. Yep. But anyway, going back to the UI, yes, so the client latencies are pretty bad for this particular setup. So this is something that we have to figure out. But anyway, the point is that this setup is ready to play with. And we are now ready to do demos using Scylla Cloud X using this particular tool. So what is the progress like? Is it done or not yet done? Yeah, so now it's showing 50%. So it is progressing very slow. Not sure what is happening in the backend, but it is working. So it is basically 3 nodes will be added and 3 nodes will be removed. So maybe it's still doing that. Yeah, so maybe node status. So how many nodes are there? So eventually I think it will still get total 6 nodes. So those nodes are leaving. So that is why there is no load on that particular node because that is leaving the cluster. So that makes sense, total sense. So this one is 155 and 35. So let's look at the monitor. Monitor. Okay. So it's still not refreshed. Give it a minute. Yeah, so 35, yes. So 35 is one of those nodes that is leaving. That is why it has almost no load at all. So it is draining and eventually going to leave. So that's what's happening. And what's happening with the tailing of logs. Yeah, so they are now coming down because now I think the draining is completed, and now the cluster is getting into better health. So it is getting more stable and the client latencies are actually dropping. So this is good. All right, I think that's all. I've spoken enough enough today. So I'll share this recording with you guys.